Okay, in this video I'm going to show you how to solve a problem involving differentiation. It says that if y is equal to 2x plus 1 over the square root of 2x minus 1, find dy dx at x equals 1. So this simply means that given this function, you have to differentiate the function and substitute the value of x, which is equal to 1. And after that, and that's the answer. But how do we differentiate the given function y equals 2x plus 1 over the square root of 2x minus 1? As you can see, this is a quotient of two expressions. And we know in differentiation that there is a quotient rule. That's the rule that you can simply apply for the quotients or the quotient of two expressions. But how is the quotient rule being applied? So let's start with the rule, the quotient rule. Now there is, we can call it a formula to easily remember the quotient rule. That is simply, we use the low, the high, minus high, the low, all over the low squared. So we name the denominator as the low, and we name the numerator as the high. And once we do that, it will be easy for us to follow the rule. So low means simply copying the denominator. So this is the square root of 2x minus 1 times the high means derivative of the high, the numerator. The derivative of the numerator 2x plus 1 is simply 2. And then minus high. This time we copy 2x plus 1 and then multiply it by the derivative of the low or the denominator. Now take note that the square root of 2x minus 1 can be written as 2x minus 1 raised to 1/2. So if I get the derivative of this is 1/2 2x minus 1 raised to negative 1/2. Negative 1/2 came from 1/2 minus 1, and then multiply it by the derivative of 2x minus 1. So remember, you should use the chain rule properly. So the derivative of 2x minus 1 is just 2. And if you simplify this 2 will cancel with the 2, and this is equivalent to 1 over 2x minus 1 raised to positive 1/2. But for the meantime, we can just use the 2x minus 1 raised to the negative 1/2. So you have 2x minus 1 raised to negative 1/2. Then everything over the low squared, when you square the 2x minus 1, square root, so when you square this, by definition, this is the absolute value of 2x minus 1. Okay, a square of the square root is equal to the absolute value of the expression inside. So this will become absolute value of 2x minus 1. Now take note, this is finding the derivative at x equals 1. So some people would want to simplify it further, but you have to check first, what do you want to do? What we want to do here is, once you found the derivative of the y, we simply put the x value, which is 1, so that we can get the value of dy dx at x equals 1. So for the case of 2x minus 1 raised to negative 1/2, you might want to rewrite it already into 1 over 2x minus 1 raised to 1/2. So this is 1 over 2x minus 1 raised to 1/2. But then again, raising it to 1/2 means square root. Okay, so this is still in the numerator. So after that, we supply, so when x is equal to 1, this is the square root of 2 times 1 minus 1, so that is 1 times 2 minus 2 times 1, that's 2 plus 1, that is 3, and then you have 1 over 2 times 1, this is 2, minus 1 is 1, the square root of 1, everything over the absolute value of 2x minus 1. So you have absolute value of 2x minus 1 when this is 1, 2 times 1 minus 1. So this is the absolute value of 1. And then simplify it further. Square root of 1 is just 1. So 1 times 2 is 2. Square root of 1 is 1. So 3 times 1 over 1, or just 3 times 1 equals 3 over the absolute value of 1, which is just 1. 2 minus 3 is negative 1, and then denominator is just 1. Negative 1 over 1, or positive 1, is negative 1. Okay? So the derivative of y equals 2x plus 1 over the square root of 2x minus 1 when x is equal to 1 is equal to negative 1. Okay, so just to sum up the procedure, first we needed to understand what we really have to do here. We want to find the derivative when the value of x is equal to 1, so that's what we did. So we differentiate the y function. Since this is a quotient of two expressions, we use the quotient rule. Make sure that you apply the quotient rule properly, and after doing that, you just have to look for some expressions that can be simplified, and then just substitute the value of x, which is equal to 1, to find the answer. Okay, so that's it. Thank you. Now, some people might be intrigued with the low d high minus high d low over low squared formula. So I will be stating a more formal way of saying the quotient rule. Now, given a new function h of x equals, say, a quotient of two functions f of x and g of x, the derivative, which is h prime of x, is equal to g of x f prime of x minus f of x g prime of x, everything over g of x quantity squared. So this is the more formal way of looking at the quotient rule. Okay, so when you look at it, this is your low, the high derivative of f of x minus high, the function x, or f of x, times derivative of the low, so g prime of x, over low squared. Okay, so that's how we got the low, the high minus high, the low over low squared. We use that just for us to easily remember the rule, but that's not the formal way of saying the quotient rule. Okay, that's it.